All right, well, let's greet each other properly. This is Mr. Ainsworth. Good morning, guys.
Good morning.
All right, we're going to get into example number 5 on linear programming, and we're going to discuss the diet problem. Okay, so we're going to read it step by step. We're going to fill out the table like we have been doing, and just take piece by piece and dissect it and see how it goes. So the diet problem goes like this. It says the diet requires at least 16 units of vitamin C. Now, a unit could be a gram. It could be a milligram. It could be anything. In general, they call it a unit. And that we should underline that because that part's important. Okay. In fact, the words "at least" are important. At least 16 units of vitamin C. And at least, it says, at least 34 units of vitamin B. Okay, so we need, obviously, vitamin C in our body and vitamin B to be healthy. Okay, and it says right here that we need at least 16 units. So I ask you, and here's the big first question here. If it says at least 16 units of vitamin C, does that mean 16 or less or 16 or more?
16 or more.
Okay, at least 16, 16 or more. Okay, or more, at least. At least means 16 or more. At most would mean 16 or less. At least means 16 or more. So I see an inequality in my mind. Guess what I see?
Equal.
Not just equal. If it's 16 or more, it's got to be what? Greater than or equal to or less than or equal to? Greater than or equal to. So right here, when I see the words at least, those are key words right there. Greater than or equal to, greater than or equal to 16. That's for the vitamin C now. Okay? So what I'm doing is I read the problem is I'm interpreting the language, because that's the key part and the hardest part in any word problem is interpreting the language. So we have to have at least 16 units of vitamin C, and it says at least 34 units of vitamin B, and that means 34 or more, so we got to go greater than or equal to 34, and that refers to the vitamin B in the supplement. Because, we got to have both. You can't just have vitamin B, you can't just have vitamin C or E or D. You got to have a little bit of everything in the right amounts to be healthy. All right, and that's part of the diet. Now, it says we have 2 food supplements that are available. All right, and the names are right here. Just take a look on the left here. We call them supplement A and supplement B, just to be in general. So we got supplement A here, we got supplement B here. I know you don't have the little pictures on your handout. I kind of just put those in there. All right, so we have these 2 supplements, and inside the 2 supplements, we'll call them A and B, are vitamin B and C in certain amounts. And what we need to do is make sure that we take enough so that we're healthy in our diet. So 2 food supplements are available. We're going to call 2 food supplements. We're going to call them A and B. All right. In reality, they have names. All right, and you just go to the health food store and you can check out all the different types and the different names. But we're going to call them A and B as their general names, and that provide the nutrients in amounts that and costs that are shown in the table. So the amounts are in the table for C and B. The costs are also in the table. Just take a look at the costs. It costs different amounts. For supplement A, it's 3 cents per gram. For supplement B, just go straight across, costs 4 cents per gram. So you can see that supplement B costs more than supplement A. Who's with me on that? All right, just reading the table here. Also, look at the different amounts. In supplement A, it has 3 units per gram of vitamin C and 2 units per gram of vitamin B. Compared to supplement B, it has less vitamin C. It only has 2 units per gram. But it has more vitamin B. It has 6 units per gram. So they're different supplements. And the question is, right up here, it says how much of each, put the word supplement right here, how much of each supplement, not vitamin C and vitamin B, okay, it's not asking that, it says how much of each supplement, because we're referring to this right up here, should be used to minimize, underline that big word. Ooh, this is a minimization problem. We haven't talked about that yet, this is new. To minimize the cost. You want to minimize the cost. Okay, so let me write that down. So how much of each supplement, okay, either A or B, how much of each, A and B, not or, but and, how much of A and how much of B should we use to achieve our, achieve our goal, and that is to minimize, okay, the cost. So we need to write a cost function and minimize it. Okay, that's a big job. So what we need to do is define some unknowns. It says how much of each type of supplement. We got A and we have what? B. And we don't know how much of each. And notice that all of these units, look at this. This is per gram, per gram, per gram, per gram, per gram, per gram. Everything's in terms of grams. G stands for grams. Who already knows that? G stands for grams. Okay, what's mg stand for? Yeah, milligrams. Okay, but G stands for grams. So when we define our variables here, and since I'm trying to figure out how much of each supplement we need to use, the amount is in grams. So I'm going to let X refer to the number of grams of supplement A, because I don't know how many grams we're supposed to use. Let's write that down. So X refers to the number of grams of, you can spell out grams, or you can put out G right here, of supplement A. And then Y is going to be equal to the number of grams of supplement B. I'm going to let X be the grams of supplement A, and then, of course, Y is the number of grams of supplement B. And then from there, I can work through the table. I have to translate the table into some inequalities so that I can try to solve the problem. I'm also going to put the variables up here, too, as well. I know in our supplement column here. So X refers to the number of grams here, and then Y refers to the number of grams here. I'm also going to put down our minimum requirements too. Look at the bottom row. It says minimum amounts. Now in a diet, it's a minimum problem because you not only want to minimize the cost, but you also have to have a minimum requirements of B and C in your body, as well as E and D and everything else. Now it says up here in the very beginning, it says at least 16 units of vitamin C per gram. So what we need to do is come down here in our table in the second column in the bottom row and put down greater than or equal to right here, 16, which represents the minimum amount of vitamin C. At least 16, which means greater than or equal to 16. And then over here on the bottom row of vitamin B, we got to put greater than or equal to the 34 because it says at least 34 units of vitamin B. We haven't seen a problem like this. Most of the time we were working with maximization problems and dealing with less than or equal to. But this problem says at least, which means that or more or greater than or equal to. So we need at least 16 units of, again, this is vitamin C. Look at this, vitamin C. And then we need at least 34 units of, or grams of vitamin B. So here we go. Once you take it and translate the problem there, what we need to do is write down some constraints. Now, constraints are limitations, as you guys know already. And there's a constraint on vitamin B. We need at least 16 units there. And we have a constraint on vitamin B. We don't have a constraint on the supplement. We have a constraint on the vitamins. Okay? So what I'm going to do is I'm going to take this down right here, and I'm going to write down the constraints and translate it into inequalities. So let's go ahead and do that. We've got one for vitamin C, and we also have a constraint for vitamin B. So we're going to do one at a time. All right, and here's how we play it. And this is where I want you guys to get involved. Bring your eyes up here when you're ready. All right, you've heard me do this before, and so let's do it again so we can see how it's played. So get your eyes right here in the vitamin C column. It says 3 units per gram. Okay, so for 1 gram of supplement A, eyes up here. For 1 gram of supplement A, we have 3 units of vitamin C. 1 gram. For 2 grams, how much vitamin C? 6 units. For 3 grams?
9.
Good, 9. 3 times 3 is 9. For 4 grams of supplement A, how much vitamin C?
12.
Very good. And aren't you multiplying? You went 2 times 3, and then you went 3 times 3, and 4 times 3. You're multiplying. We've done that in every single example. So to figure out how much vitamin C you want in supplement A, you take the quantity, 3 units here, and you multiply it by how many grams you have, and in this case, X. So we have 3X grams of vitamin C, plus, now move your eyes right here, we have 2 units per gram for vitamin D, so we got to take, I'm sorry, forget the vitamin D, we're working on vitamin C. We got to go down instead of across. We got 2 units per gram of vitamin C for the supplement B here. So we've got for one gram for supplement B, we've got 2 units for 2. For 2 grams, how much do we have total? 4. For 3 grams? 6 in total. And then for 4 grams? 8. And so you're multiplying again. So you want to take your 2 and multiply it by your Y. So for supplement A, we got 3 times X. for B, we got 2 times y, and that's got to be what here? Read it. Greater than or equal to 16. This example is different because my minimum requirements are down below here, and we look vertically, versus the previous examples, you look horizontally. It's a little bit different example. So right here, look right here where I'm pointing, we got 3 times x units of vitamin C for the supplement A, plus 2 times y units of vitamin C for supplement B, and all that's got to be greater than or equal to 16, because it says in the problem that we have to have at least 16 units of vitamin C. So you got to look vertically now, not horizontally. So let's write that down. We've got 2x here. No, excuse me, 3x. Let me get my glasses on here. So we've got 3 times x units for the vitamin C coming from supplement A. So 3x plus 2y is greater than or equal to 16. That's our minimum. Now what we need to do is take a look at this right here and also translate that. We need a constraint, or write a constraint on vitamin B. And we do it in the same fashion. We take the number of units per gram. Look up here. We've got 2 units per gram of vitamin B for supplement A. So we've got to take 2 times x plus what here? Everybody? Let me hear you. So we've got 2x here plus 6y. That's got to be greater than or equal to 34, because it's a minimum requirement. You've got to have at least 34 grams, or units, excuse me, of vitamin B for your diet. So we've got 2x here plus 6y plus 6y is got to be greater than or equal to 34 units. Okay, so we got our constraint for vitamin C, we got one for vitamin B, and now we got to write our non-negative constraints. Non-negative constraints. Now since x stands for the number of grams, it can't be negative. It's got to be 0 or positive, and that's why we call our non-negatives. So your x, since your x stands for the number of grams, that's got to be greater than or equal to 0, and likewise with your y. Those non-negative constraints are going to be in most linear programming problems, because your variables in this case can't be negative. They either have to be 0 or positive. That's where the name non-negative comes from. Non meaning not. Okay. Okay, and lastly, what we need to do is we need to take a look at our cost function. We want to minimize, look at this, we want to minimize our cost. That's our goal. That's the objective in the problem. All right, and that, my friends, is found by looking right here up in your cost column, right here. So what we need to do is take this, and we need to write a cost function. So let's go ahead and do that. So let's play the number game again. So bring your eyes right here. For 1 gram, how much does it cost for supplement A? Now, you guys are really weak. Here's supplement A in the first row, okay? For 1 gram, it's 3 cents. For 2 grams? 6 cents, right? For 3 grams? 9 cents. Aren't you multiplying in your head? Right? For 4 grams, how much? 12 cents. But in general, we've got X grams. So what's the cost for supplement A? Let me hear you. 3X for supplement B? 4Y, 4 times Y, okay, and that's in cents per gram. So what we need to do is write a cost function here. So let's go down here, and we've got 3 times X plus 4 times Y equals cost. We got to write a cost function. So cost, or you can say C for cost. C equals 3 times X plus 4 times Y, and this is in cents. Okay? So, after you do all that, then you got to go to work. That's the hard part right there. For anybody, because these problems vary so much, translating the information into a system of constraints and inequalities is the hardest part for anybody. And then the rest is algebra. So let's go ahead and go for it. We're going to call this inequality 1 and this one number 2. I'm going to come over here and we're going to isolate y. We'll do that together here. So let's take 3x plus 2y is greater than or equal to 16. And let's go for it. And let's isolate y so we can start graphing the system so we can find our corner points so we can minimize the cost. So let's subtract 3x. Okay, and you get 2y is greater than or equal to now, difference, negative 3x plus 16. Okay, you got to isolate the y by dividing everything by 2. So you got to divide by 2, and you get y is greater than or equal to negative 3 halves plus 8. Here, I can already see my slope here and my y-intercept here. Okay, who's good so far? Give me a thumbs up if you're good on the algebra. Okay, you guys remember this, even though it's a video, you can jump in and ask questions at any time, get involved, and I'll answer anything you like. Okay, inequality number 2 on the vitamin B. Okay, so vitamin B, we have 2x plus 6y, this is a 6. 6y is greater than or equal to 34, because that was a minimum requirement. So again, let's subtract 2x here, and you get 6y is greater than or equal to negative 2x plus 34. Okay, who's working ahead of me, by the way? Yeah, a lot of you. Very good. That's a sign of a good class. Okay, so divide everything through by 6. So y is greater than or equal to, let me see, negative 2, 6. What's that reduced? Negative 2, 6. Negative 1/3. Very good. So negative 1/3 x. Now, 6 doesn't divide evenly in 34, so we're going to get a fraction, so we'll just go with the flow. 6 divides into 34 5 times, right? 5 times, and 5 times 6 is 30, so we have a remainder 4. So who sees in their mind 5 and 4, 6? Who sees that? 5 and 4, 6? But what's that reduced? 5 and 2/3. So we got to simplify our fraction. If you need to do this on the side, go ahead and do that. All right, look at this. You just bust out your mathematics and you get 5 and 4, 6 or 5 and 2/3. Okay, always do your arithmetic on the side. And you got to see the slope and you see the y-intercept. And don't freak out on the y-intercept there. I know it's 5 and 2/3. It's between 5 and 6. Don't worry about it. We're just going to go with the flow and it'll turn out just fine. Okay, and now the time is to start graphing. So let's go there. Let's take a look at inequality number 1. We're going to, let me just make the numbers bigger so you can see them on the screen better. Okay, so starting at 8. So let's plot a point at 8 right here. That's our y-intercept. Put your pencil there. We're going to go down 3, right 2 from that point. Down 3, right 2. So we're going to go 1, 2, 3, right 2. Repeat it, everybody, a lot of times. 1, 2, 3, right 2. And just repeat it again. 1, 2, 3, right 2. And you're right here. Get your straight edge out and draw a very, very thin, accurate line. You want to be really exact on this example. Like that's not exact enough, so let me do that again. That's good. Okay. Now this one's different. Check this out, guys. This one is greater than or equal to. Greater than or equal to. So solid or dotted on the boundary line? Solid. Very good. Now this one's greater than, not less than. So is this above or below? Above. Very good. Above. So greater than, above. So use the arrow technique right here and describe where the solutions are and label this inequality 1. Okay, label it number 1 for inequality 1 so that when we refer back to it, we know which one we're talking about. That came from the first one. All right, I see the 4-color pen back there. We should get more of those. Those are cool. Okay. Okay, number 2. I'm going to switch to blue now. This one's a tricky one. Pay attention. This one we have to plot 5 and 2/3. Now, 5 and 2/3 is between 5 and 6. So watch me up here on the screen. 5 is right here. And what I'm going to do is divide the unit up into 3 equal parts because I have to plot 5 and 2/3. So the first mark is 5 and 1/3. The second mark is 5 and 2/3. Give me a thumbs up if you're understanding me right here. Okay. If I'm plotting thirds, I got to divide it up into 3 equal parts. The first part is 1/3. The second part's 2/3. Yes. Okay. So put a point here at 5 and 2/3. That's your y-intercept right there. 5 and 2/3. So 5 and 2/3. Now, watch first. Watch me do this. Watch me use the slope here and watch how I estimate my points, and then I'll give you time to plot it on your own. So watch this. I've got my pencil right at 5 and 2/3. I go down. Let me see. My slope's negative 1/3. I got to go down 1, right 3. So I go down 1 right here. 1, 2, 3. Plot a point. Down 1. Ooh, I just hit the line. No, excuse me. I'm sorry. I didn't mean to say that. Go down 1, right 3. 1, 2, 3. Repeat. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Repeat. Down 1, 1, 2, 3, and repeat, and it keeps on going. So I take my straight edge out and draw a nice accurate line here. Right about there. Okay, now you guys try it. Okay, put your pencil at 5 2/3 and go down 1. You're in between the grid lines now. You're in between the grid lines because you're going down 1 unit, and then right 3, and then repeat it, down 1, right 3, and you're in between the grid lines on each one. Now that's greater than or equal to 2, so I'm going to go up on this one. Okay, I'm going to label this inequality number 2. Label your inequality so you know what you're doing. Okay, that'll be important here in just a minute. Okay, now switch colors. I'm going to go to green. This one here, x greater than or equal to 0. We got to graph our non-negative constraints too, and the x greater than or equal to 0 is going to be a vertical boundary line. It's going to be the y-axis up here. When x is greater than or equal to 0, you're to the right of the y-axis. In all our examples and all our lessons that we've done, and I've done this over the last 2 weeks, x greater than anything, greater than or equal to either 1 or 0 or 5, I don't care what the constant is, there's always a vertical boundary line. In this case, it's greater than or equal to 0, so it's to the right, as opposed to less than or equal to 0 is to the left. So label that. I'm going to go to red now. This one here, this one's a horizontal boundary line above the x-axis here. So when all y values like 0, 1, 2, 3, and all these are above the x-axis. So you go above, right here. I'm going to make them even longer, okay? So you can see the intersection there. And this right here in red is y greater than or equal to 0. So there we go. We've graphed all 4. The question is, where do they overlap? Because this example is way different than the previous ones. In the previous examples, the maximization problems, we ended up with like polygons in the shape of like triangles, and sometimes we had 4-sided polygons, which are called quads. But this one's different. The area where they overlap is not inside this little bounded region here, because that's only where the green and the red intersect. We want the black intersecting with the blue, intersecting with the red. So look at this. Red's all the way up. Green, which is x greater than or equal to 0, is all the way to the right forever. Black is up, blue is up, and the only place where they intersect is way up in here in the upper region, and it's not bounded this time. It's unbounded because these go on forever. This is the first example that you've seen where the solution region, called the feasible region, is unbounded. It's up here. Who sees that, by the way? Who's with me on that? All the colors intersect all in this upper region right here. So get your highlighter out. We're going to highlight, well, you can watch me first, and then that entire region up there. So let me get my highlighter. This is the bounded region here. So go ahead and shade this in. Use your highlighter. It's unbounded. It's your first unbounded case, and typical minimization problems are like this, okay, where this feasible region is unbounded. This is called the feasible region. Another name for that is solution region, or solution region. And what we need to do here is take a look at the corner points, find the vertices, and minimize the cost function for this diet problem. Okay, so we got to find the vertices, and vertices, corner points. I see one right here, so let's call them A, B, and C, like I always do. Here's A, right there. I see another one right here, B. And then if I extend the x-axis, I'm going to extend it because we need to right now. Watch this, guys. I need to extend the x-axis way over here. Whoa, I went crazy right there. Hang on, let me try it again. There, that's good enough. Right there. Okay. So, and I see one right here. This is point C. The question is, what is point C? A and B we can see, but point C we're going to have to figure out, and I'm going to share an insight with you on point C, how to figure that out, because that is an x-intercept, And we know how to find x-intercepts in here. Okay, so point A, give me some energy now. This one you can easily identify. All right? It's up 8 units on the y-axis. So everybody, what are the coordinates? Yeah, 0, 8, that's what I heard. And this one, you can identify this one too. Look at this. Over how many? Over 2, up. 1, 2, 3, 4, 5. Give me the coordinates. 2, 5. Okay, so point A was 0, 8. Point B is 2, 5. The question is, what's point C? Now, bring your eyes right here. Who sees that this is an x-intercept because it intersects the x-axis? Who sees that? Now, x-intercepts have a what y-coordinate? What's the y-coordinate right here? Eyes up here, guys. What's the y-coordinate on this point? Not the x-coordinate, the y-coordinate. It's 0. And right now, since we can estimate it, this looks like 15, 16. It could be 17, but is it 17? So the question is that 17? So what we're going to do, since we know it's a y-intercept and it has a y-coordinate of 0, we're going to take inequality number 2. Look where I'm pointing. This is inequality number 2, which is the one in blue right here, the 2x plus 6y greater than or equal to 34. We can take y, substitute 0 in for y because it's an x-intercept, and solve for x, and make sure it's 17. Because graphs are a little bit, I mean, we're human here. They're not totally accurate. We could be off a little bit. It could be 17.5 or 16.5. We really don't know. So I'm going to take this inequality, the second one. I'm just going to work in our feasible region where we have some room. Actually, no, I'm going to go to the margin. And we are going to find the x-intercept. Work with me, find x-intercept. This is inequality number 2. So 2x plus 6y, I'm going to switch to equal sign because the boundary line is an equal sign, equals 34. Whoops, not 6x, but 6y. Sorry. All right, and I'm going to find the x-intercept. What in the world is the x-coordinate on point C? So I let y equal 0. So let's substitute 0 in for y. So I have 2x plus 6 times 0 equals 34. Okay, we know 6 times 0 is 0. So I have 2x equals 34. And we got to divide that by 2. And do you guys know what 34 divided by 2 is? Tell me. 2 times 12 is 24. 34 divided by 2 is? Yeah, just do it on the side. 34 divided by 2, you get 17. All right, so the x-coordinate is 17. And I did that for you guys because sometimes you don't know. Like right there was a little vague. I wasn't sure whether it was 17 or not. So use your previous skills. It's an intercept. So when we find intercepts, you always use zeros. So put 17 right here. This is 17, or 17, 0 for point C. So C is 17, 0. Let's write down our vertices here. A was 0, 8. These are vertices. All right, B is 2, 5. And 17 is, point C is 17, 0. And those are the only 3 vertices we have. One of these minimizes the cost of the cost function. So let's take our cost function down here, 3x plus 4y. And let's write down our vertices. We're going to take each vertex and we're going to substitute it excuse me, into our cost function. And we're going to figure out what combination of the supplements, supplement A and B, minimize the cost, but satisfy our minimum requirements for vitamin B and C so that we're healthy on our diet. So we've got point C here, which is 17, 0. All right, so here we go. Remember, on all these points, it's x and then y, x and then y, x and then y. So when we substitute our vertices in, we just basically put them in wherever we see the variable. So we've got 3 times something plus 4 times something. You got to substitute 0 in for x, 8 in for y, multiply the terms together, use a little bit of order operations, and see what you get. So I'm going to put 0 in for x, 8 in for y. You guys tell me, what's the cost for the first solution here? 32 what? Look at the table. No. It's a cost. It's a cost. Look at the table. What does it say? It says cents. Cost is in cents. All right, so this is 32 cents. So put a cent sign and put down 32. All right. On the second one, the cost is 3 times 2 plus 4 times 5. Well, let's figure that out. So, what do we have? We have 6 here, and we got 20 here, and 20 plus 6 is 26. Okay, 26 cents. All right, per gram for that solution there. The question is that the minimum? I know 26 is less than 32, but is that the minimum? I don't know. So we got to figure it out. So 3 times 17 plus 4 times 0. Is this the minimum? You guys know what 3 times 17 is? Yeah, 51. So 51 cents. So the cost here is 51 cents. Let me see. We've got 32 cents. We've got 26 cents. We've got 51 cents. We're trying to minimize the cost. All right? We're trying to be healthy, but we don't want to spend as much. You don't want to spend a lot. You want to spend the least amount, right? You want to minimize it. All right? So what's the minimum? 26 cents. Okay, so let's identify that. This is our minimum cost right here, and we achieve this by doing this. This is our solution right here. The cost is not the solution. The point is. So we got to interpret the point. So what you do is you go back up to the top, and you got to remember, what does X stand for? So look at your variables up here. Look at the screen up here. X stands for what? Read it. Grams of supplement A. So X is supplement A, grams of supplement A. Y is grams of supplement B. So when we go down here and interpret our solution, which we need to do because we always have to do that in a linear programming problem, right here, what's our optimal solution? We need 2 grams of supplement A and 5 grams of supplement B to minimize the cost and still keep the minimum requirements of vitamin B and C. So let's write that down. We need, it says 2 grams of supplement A and 5 grams of supplement B, all right, to minimize the cost. To minimize cost, okay, which is equal to 26 cents per gram. 26 cents per gram, and still keep the requirements. And still, I'm going to write that down too. And still, oops, got to spell that right. And still keep the minimum requirements of vitamin B and C. Of vitamin B and C to be healthy. The healthy. There we go. All right. This right here is the main part of the solution right here. This tells us what kind of combination we should use to keep our minimum requirements, but also keep the cost down because, as you guys know, supplements cost money. You go to GNC or a health food store, it costs a lot of money. I just bought some food supplements the other day, and one bottle of a whole food supplement that I take every day, twice a day, is $45 for just the bottle, and that's a 1-month supply. And then I needed to get a couple other ones too, so you can see the cost adds up pretty fast. So what you want to do is you want to try to meet your diet requirements, but also minimize the cost so you don't keep on spending a whole lot. Because you got a lot of other things to get too, especially if you have a family like I do. Okay, but that's it, right there. That's your first minimization problem, and what you guys need to do is experience the other ones. So that's it on number 5, and I'll see you in the next one.